So, hello dear students. As promised, today I am starting a new course for class 9th. That is for chapter 2, motion in one dimension. And this course is for ICSE students. This course is specially designed for ICSE students. And I will just cover the books of ICSE also, that is on the innovative and Salina book. So, students, today we will start our new course, that is motion in one dimension, chapter 2, class 9th ICSE board. So now, next. So now, students, first topic is scalar and vector quantities. I think you might have studied in your class 8th and 7 what are scalar and vector quantities. So students, before starting scalar and vector quantities, first we will see what are physical quantities. So students, the quantities which we can measure are called physical quantities. The quantities which we can measure are called physical quantities. And example are mass, length, time. Students, these quantities are measurable. These are those quantities which we can measure. And students, these are called physical quantities. And students, physical quantities, your physical quantities, students, they are classified into two parts. What are they? Scalar and vector quantities. So students, next we will see scalar and vector quantities. Now students, first we will see scalar quantities. What are scalar quantities? So students, the physical, here it will be quantities, the physical quantities which are expressed only by their magnitude. They are called scalar quantities. Examples are mass, length, speed, distance, temperature, pressure. Students, these all physical quantities, they are expressed by their magnitudes. So they are scalar quantities. Suppose students, if I am saying mass of a body is, if I am saying mass of a body is, and it is how much? 0.5 kilogram. So students, if I am writing mass of a body and it is equal to be 5.0 kilogram, then the students, it has complete meaning. It has a complete meaning. And students, we are completely expressing the mass of a body. If I am saying mass of a body is to be 0.5 kilogram, means it has complete meaning. And students, we represent physical quantities. We write physical quantity in the following way. Physical quantities, students, it is equal to physical quantities. Students, it is equal to numerical value into unit. Numerical value into unit. Here, what is numerical value? Numerical value is 0.5. It is number, and kilogram is what? Unit. So students, we have written our physical quantity, that is mass, in terms of numerical value and unit. That's why this physical quantity has complete meaning. So students, this is all about physical quantities. Now, so next is scalar quantities can be added, subtracted, multiplied, and divided by simple arithmetic methods. Suppose that students, if you have two physical quantity, mass of body 1, it is 0.5, and mass of body 2, it is 0.4 kg, then students, they both are scalar quantities and they both are physical quantities also. So students, these mass m1 and m2, they can be added, subtracted, multiplied, and divided. If you will add this, how much it will come? M1 plus N2, 0.9 kilograms. Similarly, you can multiply, divide, and subtract. So now, students, next we will see vector quantities. Now, see what are vector quantities? Those physical quantities which require the magnitude as well as direction to express them. Only their meaning is complete. So, friends, these quantities are called vector quantities. Examples are displacement, velocity, and acceleration, force. These all are vector quantities. Now, students, let me give you one example. Let me give you one example. Suppose if I am saying uh, displace a particle from a point by 5 meter. Displace a particle from a point by 5 meter. Now, students, first question here arises, in which direction we will displace this particle? I am repeating once more. Suppose if I am saying displace a particle from a point by 5 meter. Now the question will arise, in which direction we will displace this particle? Suppose that if we are saying the displacement is 5 meter. If I am saying displacement is how much? 5 meter. Displacement is 5 meter. Now, students, if I will say displacement is 5 meter, its meaning is incomplete. Students, its meaning is incomplete. Its meaning is incomplete. Now, friends, next is if I will say displace the particle from that point 5 meter towards east direction, towards east direction, towards east direction. I am repeating once more. If I am saying displace the particle from a point by 5 meter towards east direction or in any other direction. Now, students, then it has a complete meaning. So students, what is the consequence of this? So we require the following 3 meters to express a vector quantity. What are they? We require 3 parameters to express a vector quantity. And students, what are they? First is unit. Second is numerical value. Second is numerical value of the quantity. And third is, students, direction. Direction. So, student, valid physical quantity with direction is the method of expressing a vector. So, I think it is clear to you all. You can note it down also. Now, student, next is good example of force. Vector is force. And students, suppose if you have any body and if we are applying force, then the body will start to move in the direction of force. So you can just imagine, just understand from this. For good example of vector is force. Now, so next is how to represent a vector quantity. A vector quantity is written with an arrowhead over its symbol like A, like this. Now, so suppose if we have a physical quantity A, and if it is a vector, then we will represent like this. We will put an arrowhead on the top of this symbol A. Now, students, this arrowhead, it will represent direction. It will, students, represent direction. And student, it will represent what? This line. It will represent magnitude. It will represent magnitude of the vector. So this was all about vector quantity. Next. Now, so next is rest and motion. Also, it is very simple. You are studying from your previous classes. A body is said to be in rest if it does not change its position with respect to immediate surrounding, while a body is said to be in motion if it changes its position with respect to its immediate surrounding. So this is all about rest and motion. I am not going in detail of this because you already know all this. Now next, one-dimensional motion. Now, what are one-dimensional motion? When a body moves along a straight line path, its motion is said to be one-dimensional motion. So friends, clearly, if a body is moving along a straight line path, its motion is said to be one-dimensional motion. And students, there are other dimensional motion. Second is two-dimensional motion. Two-dimensional motion. Two-dimensional motion. Two-dimensional motion. What is this? Here we will see. Now, friends, suppose that if a body is moving along a plane, if a body is moving along a plane or along a curved path then students, what will happen? Then the motion of this body is two-dimensional, and next is three-dimensional motion. So that if a body is moving in space, then the motion of the body is said to be three-dimensional. But students, here we are studying motion in one dimension. So here we will consider only one-dimensional motion. So students, we will study about this in detail. Let's start. So friends, this was all about one-dimensional, two-dimensional, and three-dimensional motion. But students, here we have to study about motion in one dimension. This chapter deals with motion in one dimension. So here we will consider only one dimensional. Next. Now, friends, representation of one dimensional motion. We will see how to represent one dimensional motion. So, friends, a straight line parallel to x-axis. If x-axis is taken in the direction of motion, so in this way we will represent one dimensional motion. We will proceed further. As you can see, the position of a pebble measured from its starting point, falling freely and vertically downward at different instants is given below. As you can see, at different time, the motion of a pebble measured from its starting point when falling freely, and it is given below at time t equal to 0, 0 meter, 1 second, 5 meter, 2 second, 20 meter, 3 second, 45 meter, 4 second, 80 meter. As you can see, this is the representation. We will see, as you can see here, this is the representation of one dimensional motion 0, 5, 20, 45, 80 at different times. So in this way you have to. So this was all about the presentation of one dimensional motion. Now the next is distance and displacement. So this is also very important, and this is basics. Now friends, as you can see here on your screen, there is a body, and this body is moving from A to B. As you can see, A and B. So this body is moving from A to B, friends. Now, friend, the total length of path from A to B, it is called the distance moved by the body. So, friends, the total length of path from A to B is called the distance. And students, if you will see this dotted line path, this path, this dotted line path, it is called the displacement. It is called the displacement. Listen, why displacement? Because it is the shortest path to reach from A to B. In other words, we define displacement, the shorter distance traveled between initial point, that is A, and final point, that is B, is called the displacement. So this was all about distance and displacement. I think on next slide there is a definition of distance and displacement also. This is distance. The total length of path through the which a body moves is called the distance traveled by it. The distance traveled by a body depends on path followed by the body. For different parts, the distance will be same. If you will see on the previous slide, this AB, this dark path, curved path. Yes, students, the length is here different. Here the length is different as compared to this dotted path. This dotted path, the distance along dotted path, it is less. It is here less. And students, the distance along curved path, it is more. So students, your distance will depend on path also. For different paths, your distance travel will be different. Now, so next is distance is a scalar quantity represented by the symbol S. The SI unit of distance is meter and CGS unit is centimeter. Why CGS unit is centimeter? What is the full form of CGS? Centimeter, gram, and this is second. We represent length in centimeter. That's why the unit of distance is in CGS is centimeter, because distance is the length of path covered by a moving body. That's it. Next. Next is student displacement. Students, we will see what is displacement. Just the definition. The shorter distance from the initial to final position of the body is the magnitude of displacement, and its direction is from the initial position to final position. This is very important. The direction of displacement is from initial to final position. And different displacement is a vector quantity. It is represented by the symbol this. It is represented like this. And the SI unit of displacement is meter and CGS unit is centimeter. So this you know already. Now send next. Now friends, here you will see in this figure the vector PQ, this vector PQ. Now friends, this vector PQ represents 40 meter displacement. It represents 40 meter displacement. Displacement. As you can see, this is 40 meter, your diagram. 40 meter displacement in which direction? In east direction. In east direction. As you can see here. In which direction the body is moving? The body is moving in a east direction. So when this vector P2 represents 40 meter displacement in east direction. Now students, here P is the origin. It is the initial position. It is the initial position. It is the initial position of the body. And friends, Q is the final position of the body. Q is the final position of the body. Final position of the body. So students, this is the representation of displacement. I hope this is clear. If you have any doubt, then you can ask anytime. I'm free. Now next. Next, we will see distinction between distance and displacement. What is the difference between distance and displacement? Now, for distance, it is the length of path transferred by the object in a certain time. What is displacement? It is the distance traveled by the object in a specified direction in a certain time. So difference is here about direction, or in other words, it's the shorter distance between final and initial position. Distance is a scalar quantity, it has only magnitude, while displacement is a vector quantity, it has both magnitude and direction. Now, for distance, it depends on path followed by the object. It does not depend upon the path followed by the object. Distance is always positive. It can be, while displacement, it can be positive, negative, depending on its direction. Students, if you are moving in opposite direction, then then the direction of displacement will be negative. Now, friends, it can be more than or equal to magnitude of displacement. So distance can be equal to displacement or more than. Distance is never less than displacement. Displacement will always be less than distance. And friends, its magnitude can be less than or equal to distance, but can never be greater than distance. Now, friend, distance, it may not be zero even if displacement is zero, but it cannot be zero if displacement is not zero. So here is friends, It is 0 if distance is 0, but it can be 0 even if distance is not 0. So displacement can be 0 if distance is not 0. So this was all about distinction between distance and displacement. Next. So this was all about distance and displacement. Let me open another slide. This is speed. Unit is meter per second. Now then suppose if the distance is 1, 3, 5, 7, time is 1, 2, 3, 4 seconds. So here friends, we will calculate first what? We will calculate speed. Sorry. Suppose your distance is 10 meter, 20 meter, 40 meter, and 60 meter. Time is how much? 1 second, 2 second, 3 second, and 4 second. Is this clear? Then here, what will be speed? 10. What will be speed? 20. 10 again, 10 meter per second. And here it will also be 10 meter per second. Here, student, the distance will be 30 meter because we have to take equal distance now. So here it will be 30 meter, and students here it will be 40 meter. So here students, here again 10 meter per second, and here again 10 meter per second. Students, here if you will see here, the speed is constant 10 meter per second. Why? Because the body is covering equal distance. How much equal distance? 10, 10, 10 meters in equal interval of time. Time is equal how much? 1 second. So students, this is all about uniform speed. And students, if you will take unequal distance in equal interval of time, it will be called as non-uniform speed. You can just take example, take some unequal distance in equal interval of time, and if you will calculate, that will come out to be variable. The speed will not be equal, so that will be variable speed. So friends, here non-uniform speed is also known as variable speed. So this was all about uniform speed and non-uniform speed. And next is students, average speed. How to define it? Average, it is the ratio of total distance covered to the total time taken. And students, if average speed is equal to here total distance upon total time. Total time. Total time taken. So this is all about average speed. So suppose if S1 and S2, S1 and S2 are the distance covered in time T1 and T2, then how to write average speed? U average is equal to total distance is how much will be how much? S1 plus S2, and total time will be how much? T1 plus T2. So in this way you have to write. So this was all about average speed. Now next is instantaneous speed. What is instantaneous speed? We will see. So students, here the actual speed of a body at a particular instant is called instantaneous speed. And students, mathematically, how we will write instantaneous speed? Now, students, it is equal to distance. It is equal to traveled, distance traveled, distance traveled in a short time. Distance traveled in a short time. This students, you have to remember one thing: the time interval that will be very short. In a short time upon time. So students, your time interval should be very small. So friends, this is the formula of instantaneous speed. And students, if you have seen the speedometer of a vehicle, that will give the instantaneous speed. Is clear? So this is all about instantaneous speed. Next. Next is students velocity. Next is velocity. So students, when direction is mentioned along with speed, it is called velocity. So students, in simple words, if you will write speed plus direction, speed plus direction, it is equal to velocity. So if your speed has some direction, then it is velocity. Now students, next is velocity is the speed in a particular direction or is the rate of change of displacement. And student, velocity is a vector quantity. Students, how will write? Mathematical velocity vector v is equal to change in displacement delta vector s upon time interval, that is delta t. This delta is representing change. It is a mathematical symbol. It means change. Now, students, unit of velocity is meter per second and in CGS centimeter per second. Same as speed. You can just. So this was all about velocity. Now, next is instantaneous velocity. What is instantaneous velocity, students? Instantaneous velocity is velocity of an object at a particular point of its path or at a particular instant of time. So this is instantaneous velocity. So students, this is all about instantaneous velocity. So you can just see, and we represent instantaneous velocity by vector v instantaneous. Just see. So now next, uniform velocity. Now, stand if a body covers equal displacement in equal interval of time, however small these intervals may be, and student, it is called uniform velocity. This is also known as constant velocity. Practically, it is difficult to find uniform velocity because students, if you are moving on a crowded road, then it is very difficult to maintain uniform velocity. So variable velocity comes into play. So students, if you have covering equal displacement in equal interval of time, then that is uniform velocity. Suppose if I am giving you one example, suppose you have displacement. This is displacement. Okay, and this is time. Suppose students, we are covering displacement 10 and how much then 20, 30. Time in this 1, 2, 3. So here students, calculate velocity. It will be 10 meter per second. 20 upon 2, 10, 30 upon 3, 10. So here is students, it is coming out to be same, constant. So this was all about uniform velocity. Student, next is non-uniform velocity. If a body covers unequal displacement in an equal interval of time, then the body is said to be variable velocity or non-uniform velocity. For example, a car is starting from rest and gets accelerated and covers unequal displacement in equal interval time, so its velocity will be variable. So this is all about variable velocity. Now then next is average velocity. So students, here we will see what is the average velocity. So here students, average velocity is it is equal to displacement in a complete journey, displacement throughout the complete journey upon total time taken. So this is all about average velocity. This was all about average velocity. Next is students. Next is this difference between speed and velocity. It is also very important. It can come in your school examinations. Difference. Distance is it is the length of the path transferred by the object in a certain time. What is sorry, yeah, made one mistake. Here I have uploaded difference between distance and displacement. So just let it be uh, anyway. We'll see. Difference between speed and velocity. Speed and velocity. So now friends see. We will see difference between speed and velocity. Students, speed is what? Distance covered per second by a moving object is called speed, distance upon time. And what is velocity? Distance plus direction upon time. It is velocity. Now, sir, next, speed is a scalar quantity. This was first. And second is what? Speed is a scalar quantity, while velocity is a vector quantity. And student, speed is always positive. Speed is always positive, and because direction is not taken in consideration, but student, velocity can be positive or negative also, because direction is taken into consideration. And students, for this, after one round in circular path, the average speed is not zero. The average speed is not zero. But students, after completing each round along a circular path, the average velocity is zero, because the direction will change. And if you take the vector sum, it will come out to be zero. So this was all about difference between distance and velocity. And students, I have to mention one extra point in non-uniform velocity. Uniform, non-uniform velocity. See, to add one extra point, the examples of non-uniform velocity. We will see what are the examples of non-uniform velocity. Students, the motion of a freely falling body, the motion of a freely falling body, freely falling body. Students, it has non-uniform velocity. Why non-uniform velocity? Because throughout the motion of the body, uh, speed will increase. Speed students, it will increase. Speed of a body, it will increase. You can see here, if the body is at rest, if it is a freely falling body, if it has some height at rest, then when it will form, its speed will increase. So students, this is, and if you will calculate velocity at different instant of time, it will come out to be very good. So now, student, next is, if you will see for a particle moving along a circular path, suppose that a particle, it is moving along a circular path. This is a circular path. And student, then what will happen? At different points, what will be direction of velocity? You will see. Yeah, it is at point B, at point C, and at point D. So here, students, if you will see here, the direction of velocity is different at different path. It is along the tangent to the circular path. So here, students, the velocity will be different. So students, here the speed will be constant along a circular path, but different, the direction is different. So velocity will be different. So students, this is the very good example of non-uniform velocity. If a body is moving along a circular path. So students, here speed is uniform, but direction is changing at different points. So its velocity will be non-uniform. So this was all about non-uniform velocity. I hope it is clear. So this was all about for today. From tomorrow, we will start acceleration. So just follow my channel, and you can like, share, and subscribe my YouTube channel if you are liking if you like my videos. That's all. Thank you.